Solving polynomial equations. I'm asked to solve x to the 4 minus 6x cubed plus 22x squared minus 54x plus 117 equals to 0. And I'm given one of the solutions. I'm given that x equals to 3 plus 2i, which is a complex solution. So let's look at this polynomial. This polynomial is a polynomial of degree 4 because the largest exponent is 4. So this polynomial will have 4 solutions. I have that x equals to 3 plus 2i is one of the solutions. So I need to find 3 other solutions. Now, looking at x equals to 3 plus 2i, we see that it's a complex solution, and we know that complex solutions occur in pairs, and they are called complex conjugates. So immediately I know that if this my first solution is 3 plus 2i, my second solution will be 3 minus 2i, the complex conjugate of 3 plus 2i. Right, so I'm going to write each solution as a factor. So I go x minus 3 plus 2i will equal to 0, or x minus 3 minus 2i equals to 0. So if each factor equals to 0, I'm now going to multiply the two factors together. So I have x minus 3 plus 2i multiplied by x minus 3 minus 2i must equal to 0. So the product of these two factors will yield a quadratic expression, and the reason why it's quadratic is because if I multiply my first terms of each bracket, so x times x is going to yield x squared, so I'm going to get a quadratic expression of the form ax squared plus bx plus c equals to 0. And then I'm going to use that quadratic expression to try and find the other solutions to this polynomial equation. Now, we need to remove the brackets. That means we need to multiply these two factors, and I'm going to use the method that I used in the previous example. So when I remove my brackets, I'm going to do it, I'm going to say x squared minus the coefficient of x will be the sum of the roots plus the constant will be the product of the roots. Right, so let me find the coefficient of x. Coefficient of x is the sum of the roots. So we're going to find the sum of the roots. So the sum of the roots is going to be, so I'm just going to write down the word sum for sum of the roots. So the first root was 3 plus 2i, and this must be added to 3 minus 2i. And then 3 plus 3 gives me 6. So I add my real numbers, and then I add my imaginary numbers. 2i minus 2i gives me 0. So the coefficient of x is going to be 6. Let's work out the product of the two roots. So we got 3 plus 2i multiplied by 3 minus 2i. And this will give me 9 because 3 times 3 is 9. 3 multiplied by negative 2i is negative 6i. Positive 2i times 3 gives me positive 6i. And then I have negative 4i squared. I know that I squared has a value of negative 1, so it's 9 minus 1 because the middle terms cancel each other out. So this gives me 9 plus 4, which is 13, so the constant has a value of 13. So when I multiply these two products, I'm going to get x squared. The sum of the roots gave me 6, so it's minus 6x. The product of the roots gave me 13. So this is the answer to the above problem. This is actually one of the factors. I need to now find the other factors. So what I'm going to do is just recopy the polynomial. So in the question, I was given the polynomial x to the 4 minus 6x squared plus minus 6x cubed plus 22x squared minus 54x plus 17, and that had to equal to 0 because I had to solve for x. So if we just look at our polynomial, we have found out that x to the 4 minus 6x cubed plus 22x squared minus 54x plus 117 equals, so we have one of the factors here. We got x squared minus 6x plus 13, and once again I'm going to use the inspection method to work out the other factor. Now in this situation I am multiplying x squared times x squared. So if I want to find the value of my first term of my polynomial, it's 1x to the 4. So 1x squared times 1x squared will give me 1x to the 4. The next thing I'm going to look at is my constant, and the value of my constant is positive 117. So I ask myself 13 times what? I got 13 times positive 9 gives me 117. And then because the second factor is also quadratic, I'm going to write it as kx. So the coefficient of x will be k. And I'm going to use again the inspection method to find the value. So to find the value of k, I'm going to concentrate on all of the terms that so we could decide which one of these three we want to choose. But let's concentrate on all of the terms that contain the variable x. So I got minus 54x. So I need to apply the distributive rule between these two factors so that at the end my answer is a variable x only. So I know I can't multiply x squared with anything. So if I look at minus 6x, and if I multiply minus 6x times positive 9, 9 times 6 is 54, it gives me minus 54x. And then the only other term that's going to yield the variable x is if I multiply 13 times kx, and that's going to give me 13kx. You could do this with x squared, or you could do this with the x cubed terms too. Now we're going to solve for x, but we're going to ignore the variable and just look at the coefficients. So I have minus 54 equals to minus 54 plus 13k. And I want to solve for k, so I'm going to take my constant across. So I got 0 equals to 13k. So therefore, k has a value of 0. So once again, I substitute this into the right-hand side of my equation. So I have x squared minus 6x plus 13 times x squared plus 0x. So I'm just going to write plus 9. And this must equal to 0 because I need to solve for x. Right, so we then again realize that x squared minus 6x plus 13 equals to 0, or x squared plus 9 equals to 0. When we solve x squared minus 6x plus 13, we're going to come to the solution that was given to us initially in the beginning of the question. So this yields the solution x equals to 3 plus or minus 2i. These are the two complex solutions. Here I got x squared equals to 9. I'm going to square root both sides. So the square root of x squared must equal to, that will be negative 9. Must be plus or minus the square root of negative 9. So x equals to plus or minus the square root of 9 is 3. And because it's negative 9, it's going to be plus or minus 3i. So this polynomial will yield 4 solutions. 2 of them are 3 plus or minus 2i, and the other 2 are x equals to plus or minus 3i. So we have 4 complex solutions.